Welcome back to Business Statistics 207. Last video series we covered procedures for collecting data, analyzing data types, and determining data measurement level. This series we'll learn to describe the data we collected and turn it into a meaningful output. I will walk you through a few examples of graphs, charts, and tables, as well as showing you how to create these in Excel. Here are the key learning outcomes for Chapter 2. After this week, you should have a fundamental understanding of how to interpret and create frequency distributions in histograms, bar charts, pie charts, stem and leaf diagrams, line charts, and scatter diagrams. We will begin Chapter 2 with the frequency distribution in histograms. A frequency distribution is simply a summary of a set of data that displays a number of observations in each of the distribution's distinct categories or classes. It can be in a list or table form and contains the corresponding frequencies with which each data value occurs. Oftentimes data may take on only a few possible values. These data are called discrete data. When you encounter discrete data, a frequency distribution is constructed by counting the number of times each possible value occurs in a data set. We organize these data into a frequency distribution table. In this example, an advertiser asked 200 customers how many days per week they read the daily newspaper. Again, the frequency is just the number of times a value occurs, in this case, number of days read. Suppose we had a similar study with a different number of customers. We cannot compare using standard numbers. Instead, we would make comparisons using relative frequencies. This is the proportion of total observations that are given in a category. Relative frequency is computed by dividing the frequency in a category by the total number of observations, in this case 200. The relative frequencies can be converted to percentages by multiplying by 100. Playing off the previous example, we can divide each frequency for days read by 200 to yield the relative frequency. In this example, 22% of the people in the sample report said they read the newspaper 0 days per week. The relative frequency column will always sum to 100%. To create frequency distribution for discrete data, start by listing the possible values and then count the number of occurrences at each value. From there, determine the relative frequencies. Let's open up AJ Fitness from the textbook Excel files and develop a frequency distribution. Begin by clicking on the Data tab and find a clean open space to put your new calculations. Determine all possible values for the variable. Since we want overall service satisfaction, we can copy that over and create a frequency column. Determine all possible values for the variable, in this case 1 through 5. Now we'll calculate frequency by selecting these 5 rows and typing equals frequency, parentheses. Select the data we're interested in, which is overall service satisfaction. We'll go up and find our bin array, which is K2 through K6. Close your parentheses, and all at once click Control-Shift-Enter. And as you can see, we now have a frequency count for each satisfaction level. Let's try another method using pivot tables to find the same result. Click anywhere within the data, it doesn't matter where, and go up to Insert, Pivot Table, and we will want our new pivot table in a new worksheet, so we'll click OK, and we'll drag overall service satisfaction to rows and again to values. And we want to set our value field settings not to sum but to count. We'll click OK, and you can check these are the same frequencies that we obtain using the frequency function. Here we get the same result. We're letting Excel do more of the heavy lifting in this case. Frequency distributions are effective tools for describing data. Thus far we have discussed how to develop frequency distributions for one variable at a time, but suppose we want to add an extra dimension. Often we need to examine data that are characterized by more than one variable. This may involve constructing a joint frequency distribution for two variables. Joint frequency distributions can be constructed for qualitative and quantitative variables. It is a similar process as before, but now you add one more variable and count the number of joint occurrences at each row level and each column level for all combinations of row and column values. Calculating row and column totals is relatively easy if we use pivot tables. Let's go back into AJ Fitness and develop a joint frequency distribution. Again, we'll insert a pivot table, so go to Insert, Pivot Table, click OK, and create the same pivot table as before by overall service satisfaction in rows and values. Be sure to change your value field settings to count, but this time we'll add typical visits per week to the columns, so we get visits from 0 to 10 per week by satisfaction level. If you right click within the table, we can get relative amounts by changing the show values as percent of grand total. Again, if you reported this in a report or presentation, we'd probably want to bring down the decimal points to 1 or 2. So you could do that or add 1 decimal point. And that's it on joint frequency distributions. In the previous examples, the variable of interest was a discrete variable, and the number of possible values for the variable was limited to only a few. However, there are many instances in which you have variables of interest that will be either continuous or discrete, and will have many possible outcomes. Yet you want to describe the variable using a frequency distribution. In this way, we organize data in classes. When building our classes, we need to make sure that they are mutually exclusive, all-inclusive, and equal width. This way, classes do not overlap, but the classes contain all possible data values. First, determine number of classes and class width. More classes will provide more granular detail. Just be sure to avoid empty classes. Having too few may not be helpful and may compress the variation too much, thereby providing little value to the viewer. A general rule of thumb is to have between 5 and 20 classes. We can also employ the 2k greater than or equal to n rule, where k is the number of classes and is defined to be the smallest integer so that 2k is greater than or equal to n, where n is the number of data values. The minimum class width is the difference between the largest and smallest values divided by the number of classes. In this example, we sort the raw data lowest to highest and find the range. We can select 5 classes to compute a class width of 9.2. However, we need to round up to 10 so we don't cut ourselves short. Class boundaries in this case will be intervals of 10 from 10 to 50. Counting the occurrence will give us a frequency for each class. Again, we should always find the relative frequency. Here's another example of group data with the reported frequency and relative frequencies. The cumulative frequency is just the summary of a set of data that displays the number of observations with values less than or equal to the upper limit of each of its classes. Here we start with 60. The next point we add 60 and 50, so on and so forth. The cumulative relative frequency distribution is just the summary of a set of data that displays the proportion of observations with values less than or equal to the upper limit of each of its classes. Again, we start with 0.261 and then add 0.217 to get 0.478. Although frequency distributions are useful for analyzing large sets of data, they are presented in the table format and may not be as visually informative as a graph. If a frequency distribution has been developed from a quantitative variable, a frequency histogram can be constructed directly from the frequency distribution. In many cases, the histogram offers a superior format for transforming the data into useful information. A histogram shows 3 general types of information. It provides a visual indication of where the approximate center of data is. 2, it provides an understanding of the degree of spread or variation in the data. And 3, it gives us insight into the shape of the distribution. We can see whether it's flat, weighted to one side or the other, balanced around the center, or bell-shaped. Let's go ahead and open Golf Survey from the Excel files and learn how to build a histogram from scratch. Click on the Data tab. In this data set, we have 294 values. We can determine the class width using the 2k greater than or equal to n rule. And if we do that, 2 to the 8th power is 256, and 2 to the 9th power is 512. So in this case, we'll need to use 9 classes. Here, we want to find our lowest value and our highest value, as well as the range, number of classes, which we already determined, and the width. Here, the low, we can use a min function and select number of rounds per year. Find our high by using a max function. And our range would just be the difference. Classes we already determined to be 9. So the width will be equal to our range divided by our classes, which will be 2.4. And we'll want to round that up to get a class width of 3. In this case, I would insert a pivot table. So click within your data, go to Insert, Pivot Table, click OK. And go ahead and put number of rounds per year in the rows, as well as the values, and be sure that we're not summing here, we are counting. So summarize values by count. And again, we got 294, so we know that's a check. Right click in the row labels area and select group. We will start at 10, end at our highest value of 32, group by 3. Click OK, and Excel will group it for us. Click within your data, go up to Insert, and we'll select a bar chart. But this is not a histogram yet, so we need to right click on the data and Format Data Series, and under this option select gap width equal to 0. This is now a histogram. If we wanted to report this in a paper of some kind or a presentation, you'd want to make sure to format it properly so it's descriptive and appealing, add a title and axes and anything else you might want. Okay, so that finishes up frequency distributions and histograms. We'll cover it in class and do a few examples, so save your questions and start practicing.